A dwarf planet nearly 4 billion miles from the Sun may be doing something that sounds impossible. It may be cooling itself. Not with an artificial machine, not with some hidden technology, but with the haze floating through its own atmosphere. And the strangest part, scientists didn't discover this by sending another spacecraft to Pluto. They discovered it by studying faint infrared light from billions of miles away. But that's only the beginning. Because the latest science suggests Pluto may also be slowly transferring material to its largest moon, creating mysterious reddish regions on its surface. It may be producing complex organic compounds similar to the chemistry that once existed on early Earth. And beneath its frozen exterior, there may even be a hidden ocean. So how did this tiny, distant world become one of the most fascinating places in the entire solar system? Let's go back to the beginning. In 1930, a young astronomer named Clyde Tombaugh was working at an observatory in Flagstaff, Arizona. His job was incredibly repetitive. He photographed the same region of the night sky on different nights and compared the images, searching for one tiny point of light that had moved. Then he found it. A small object shifting against the background stars. That object became Pluto. For decades, Pluto was known as the ninth planet of our solar system, but in 2006, everything changed. The International Astronomical Union officially classified Pluto as a dwarf planet. For many people, that felt like the end of Pluto's story. But it wasn't. It was actually the beginning. Because for most of the 20th century, scientists barely knew what Pluto really looked like. From Earth, even powerful telescopes could see little more than a tiny blurry point. Scientists knew its orbit, but its surface, atmosphere, mountains, and geology remained largely mysterious. Then in July 2015, everything changed. NASA's New Horizons spacecraft finally reached Pluto after traveling for more than 9 years and billions of miles through space. And it had only one chance. New Horizons couldn't stop and orbit Pluto. It couldn't turn around and try again. It had to fly past. And what it saw completely changed our understanding of this distant world. Instead of a dead ball of frozen rock, New Horizons revealed mountains made of water ice, a strange blue atmospheric haze, massive regions of nitrogen ice, and a gigantic heart-shaped plain stretching across the surface. Pluto looked alive. Not alive in the biological sense, but geologically alive. Something was happening there. And scientists soon realized that New Horizons had only shown them the surface of a much bigger mystery. Because one spacecraft flyby could only answer so many questions. To understand Pluto's atmosphere, scientists needed something different. They needed to study its chemistry from Earth. That's where the James Webb Space Telescope entered the story. Unlike New Horizons, Webb doesn't need to fly past Pluto. It studies the light coming from the distant world, separating that light into different wavelengths. And those wavelengths act like fingerprints. They can reveal the molecules inside Pluto's atmosphere and tell scientists how that atmosphere behaves. But there was a major problem. Pluto and its largest moon, Charon, appear very close together from our perspective. Earlier telescopes struggled to separate their faint infrared signals. Webb's powerful instruments finally made it possible to isolate Pluto's thermal signature with much greater precision. And what scientists found was extraordinary. Remember that mysterious haze New Horizons photographed? Scientists already knew it was made partly from complex hydrocarbon particles. But they didn't know exactly what effect that haze had on Pluto's atmosphere. Then came the surprising possibility. Instead of acting like a blanket and trapping heat, Pluto's haze may actually help cool the atmosphere. The particles absorb sunlight and then radiate energy back into space as infrared radiation. In other words, the haze may be helping Pluto lose heat. It's almost as if the dwarf planet has its own natural refrigeration system. And observations from the James Webb Space Telescope have provided strong evidence supporting this idea. The result: Pluto's upper atmosphere appears to be significantly colder than earlier models predicted. Think about that for a moment. Pluto isn't simply cold because it's far from the Sun. Its own atmospheric haze may actually be helping make it even colder. And here's where the story gets even more interesting. Because this discovery may not be important only for Pluto. Scientists are now asking whether similar atmospheric hazes could influence other distant worlds, including Neptune's moon Triton. And these studies might even help researchers understand what Earth's atmosphere was like billions of years ago. If you enjoy discovering the strange science hiding in our solar system, take a second to subscribe to the channel. We cover real space discoveries and explain the science without turning every headline into a conspiracy. Now let's look at another strange process happening on Pluto. Even though sunlight at Pluto is roughly 1,000 times weaker than what reaches Earth, it still has enough energy to trigger chemical reactions in the atmosphere. Sunlight breaks apart methane molecules. Those fragments then combine into heavier compounds. Eventually, they form reddish-brown organic particles called tholins. And those particles slowly fall from the atmosphere onto Pluto's surface. The process may have been happening for billions of years. Now here's the fascinating connection. Tholins are part of a broad family of complex organic compounds that scientists study when investigating the chemistry that may have existed on early Earth. This doesn't mean Pluto has life. It doesn't. But it does mean Pluto may be acting like a natural chemistry laboratory. A place where complex organic chemistry has been running continuously for billions of years. And that gives scientists something incredibly valuable. A real-world example of chemical processes that may help us understand how the ingredients necessary for life can form. But Pluto isn't finished surprising us. Because while its atmosphere may be slowly escaping into space, some of that material may not actually be disappearing. It may be going somewhere else. To Charon. Pluto's largest moon is roughly 750 miles across, and the two worlds are locked together in a remarkable gravitational relationship. Each always shows the same face to the other. But Charon has a mystery of its own. Its poles are covered in dark reddish material. For years, scientists suspected that some of this material might actually come from Pluto. Here's how the process could work. Methane escaping from Pluto's atmosphere travels across the space, separating the two worlds. Charon's gravity captures some of it. At the moon's extremely cold poles, the methane can freeze onto the surface. Then, when sunlight returns, ultraviolet radiation and cosmic rays break those molecules apart. The fragments combine into heavier organic compounds. And over enormous periods of time, they create the reddish material covering the polar regions. So Pluto and Charon may be locked in a slow, invisible exchange. Pluto loses material. Charon collects it. And the sun's radiation transforms it. A process that may have continued for billions of years. But if you think that is strange, wait until you hear about what may be happening underneath Pluto. First, imagine standing on its surface. The sun would appear as an intensely bright point of light. The sunlight would be incredibly weak. The sky would be dark and hazy. And temperatures could fall to around minus 400 degrees Fahrenheit. At those temperatures, nitrogen can freeze solid. The atmosphere would be far too thin to breathe. And the water ice beneath your feet would behave more like rock than the slippery ice we know on Earth. But the surface itself is even stranger. New Horizons discovered towering formations of methane ice known as bladed terrain. Some of these structures rise more than 1,000 feet into the sky. They form long, jagged ridges across the landscape. Scientists believe they may have formed through a process similar to the ice formations called penitents found in high-altitude regions on Earth. But on Pluto, the process happened with methane ice over enormous stretches of time and on a scale that is almost impossible to imagine. And then there are Pluto's mountains. Some of them have enormous depressions at their summits and structures that resemble volcanic formations. But there is one huge problem. There is no molten rock on Pluto. So scientists have proposed another possibility. Cryovolcanoes. Instead of erupting molten rock, these structures could have once released slurries of water, ammonia, and other materials from beneath the surface. And that leads to perhaps the biggest mystery of all. Could Pluto have an underground ocean? Scientists don't have direct proof. But they do have clues. Some of Pluto's surface features and fractures appear consistent with the possibility of a liquid layer hidden beneath the frozen crust. The famous heart-shaped region known as Sputnik Planitia also sits above an unusual gravity anomaly. One possible explanation is that something relatively dense exists beneath it. Perhaps a subsurface ocean. If Pluto really does contain liquid water beneath its frozen exterior, the implications would be enormous. Because Pluto is tiny, it's incredibly cold, and it's billions of miles from the Sun. Yet it may still have enough internal heat to keep water liquid beneath its surface. That would suggest hidden oceans could be much more common throughout the outer solar system than we once believed. And here's the question that makes this even more fascinating. If there is liquid water beneath Pluto, could anything survive there? Right now we simply don't know. There is no confirmed evidence of life on Pluto. And there isn't even a mission currently exploring its interior. In fact, getting another spacecraft to Pluto would be an enormous challenge. New Horizons took more than 9 years to reach it. A future orbiter or lander could require decades of planning, development, and travel. That's one reason why Pluto remains so difficult to study up close. But the James Webb Space Telescope continues to give scientists another way to investigate this distant world. And every new observation seems to raise another question. Because Pluto isn't just one isolated mystery. It's part of the Kuiper Belt, a vast region beyond Neptune filled with countless icy bodies. We have barely explored it. New Horizons gave humanity an incredible glimpse of Pluto and later flew past another Kuiper Belt object, Arrokoth. But compared with the enormous number of objects believed to exist beyond Neptune, we've seen almost nothing. And that is perhaps the biggest lesson from Pluto. For years, we thought we understood the basic story. A small frozen world. Too distant. Too cold. Too insignificant. Then we looked closer. And suddenly we found atmospheric chemistry. A self-cooling haze. Organic compounds falling from the sky. A possible exchange of material between two worlds. Towering methane ice formations. Possible cryovolcanoes. And perhaps even an ocean hidden beneath the ice. Pluto was never the boring edge of the solar system. It was simply a world we hadn't looked at closely enough. And if one tiny dwarf planet can hide this much complexity, imagine what could be waiting on the countless other worlds beyond Neptune. The next great discovery may not be hiding somewhere close to the Sun. It may be waiting in the darkness, billions of miles away. So if you want more real space discoveries explained clearly without exaggerated headlines, make sure you subscribe to the channel and turn on notifications. Because Webb is still watching the outer solar system. And Pluto's story is far from over. The next observation could reveal something even stranger. And when it does, we'll be here to break it down. Thanks for watching.